recording so that you guys are ready. The parent functions is technically part of 3.4, but if you notice we taught you them in 3.5.
Yeah.
There is a little bit of reason that we rearranged 3.4 and 3.5 as far as the progress, the sequence of things goes. I like the way we adjusted it. So anyway, so this was technically 3.5, so it's mainly piecewise today, and knowing how to handle piecewise because we've already done the parent functions. So 3.5, for instance, got a little heavy. It's because it was. We loaded a lot into it, so if it wasn't submitted Sunday, that's okay. Friday, I would like to quiz on everything up to like before. What did I tell you it was? 3. You guys remember? It's going to be 3 3s and 3 5s content, stuff we learned last week. So it can include review. Everything else will feel more spread out. This unit 1 is so long compared to the other units, well, kind of the other units. And so it's, I have 3 quizzes during this unit, but most units I only have time for the 2. Like we do 3 lessons quiz, 3 lessons a quiz. Like they're just too short to do more quiz. But this first one is just so big, and it's just talks a lot about a lot of different things, and so it's important, I think, that we do quizzes in small chunks on this one. So yeah, everything up through last week, we're gonna quiz on Friday. Okay, so that doesn't even include the piecewise functions. So starting with piecewise, that'll be on your final unit 1's quiz. How many of you guys remember piecewise functions from the past? Okay,
I remember
you love them? Yay!
They're so easy.
Who hates piecewise? That's okay.
I can't remember what they are.
I
You've
mean,
never
I
had?
don't like math in general.
I don't particularly like them, but
Okay.
I don't like
I like it.
You don't love them?
But I don't like finding them.
Okay, so we don't love them? Okay.
And I like it.
So there's a few who don't love them, and there's a few who are like, they click. So I'm hoping maybe the way I teach them, they'll finally click, and you'll be like, why have I hated these? Because I like see it piecewise, and I'm like, now that I understand them, when I was in school, they freaked me out. And now that I understand them, I'm like, yeah, give me a piecewise. They're probably the easiest function.
Yeah.
So the thing about piecewise is you need to use a combination of everything you know. Domain, a combination of the parent functions, combination of evaluating functions. Everything you've learned up to this point about functions, we're putting together in a piecewise. Piecewise functions are piecing together multiple graphs as one. They're kind of cool. So even something like this that looks like they're connected, that's actually a piecewise. They look like they're connected, but they're piecewise. But not everything has to connect.
We just don't see the dots.
We just don't see the dot. And so sometimes you guys are used to piecewise, like maybe that and then another one that's separate. It's a disjoint. Or this one looks continuous, right? So piecewise can be a lot of different things, and I just hope that you guys are comfortable with them. The only thing that's different with M1050, and maybe the honors did this, I haven't seen the honors content the way they do piecewise in a while, but in Math 3, I don't think we have you evaluate necessarily. Maybe we do.
Yeah,
I'm trying to remember.
We do.
The honors did for sure. So we might have you evaluate within each of the domains and just know which one that they fall within. So remember, a piecewise says, oh, for this domain it's this graph, but then for this domain it's this graph, and then for this domain it's this graph. So if I'm asking you to evaluate f of -2, do you plug it in all 3 places? No, it's not evaluated in all 3 places, right? So, so when we up here, these very important instructions say a piecewise function is a function that is defined by 2 or more equations over a specified domain. And then right here, make sure you guys realize that you must plug in. I know some people don't like the word plug in. Plug in, like Miss. I remember Dad being like, "It's not a lamp. You're not gonna plug it in." Within substitute, but plug in within the functions domain. Yeah, you totally can. Huh? Okay, please make sure you are plugging it within where that function's domain is. Okay? All right, find f of -2. Which equation on that function is that one?
Top one.
Good. It's in this one, right? So when you guys think about your guys' graph, this top one is from like -1 down, right? So that's the one you have to plug it into. So we're gonna go 2 minus 3 times by -2. 2 plus 6 is 8. So evaluating them is pretty straightforward. How do we feel about that process so far? Good. Where is f of -1? Where does that one fall?
The second one.
The second one.
Why in the second one and not because -1 is technically labeled up top.
It's less than the middle one.
Because it doesn't have it.
Good. This one is a strictly where this function. Let's do a different color. You guys are right. You're all right. This one is included on that interval, right? So -1 isn't included on the other one's interval. That's a boundary. So remember, the non-inclusive works as a boundary. This is where it's actually included, is in this one's interval. I want these. Remember how I've talked about the gimme points?
Yeah.
These are example of gimmies. If you pay attention to inclusiveness, I promise it's going to save you anywhere from 10 to 25 points on your exams. I promise. Inclusiveness. Like, inclusiveness literally ruins some of my kids' grades because they just didn't pay attention to inclusiveness. So some of these gimmies were just, it's all just inclusive. I remember one kid, we were really fighting for a C minus so I could bump him to the C because of the 65% rule.
Ooh, this kid.
And it literally, I counted 12 points if they would pay attention to inclusiveness on the inequality question, the absolute value, all those, and just simple things like this, and we could have got into a C minus.
And now that kid's a janitor.
No, he was fine. But I'm just saying, I'm just saying.
Then he turned to drugs.
And they turned to drugs, yeah.
Drugs are all drugs.
Oh, guys. Okay, so 0 falls here, right? So 0 falls there, so that's one in the second one as well, right? Are we all feeling pretty comfortable with recognizing domain then?
Yeah.
2 falls in which one's domain?
The
bottom one. The bottom one's domain. So we get to say, oops, I said x. 2 minus 2 cubed, is that what it was?
Yeah.
I don't mind that we have a lot of fun and stuff, but sometimes the videos,
thought it was 1.
the videos are really loud with a ton of conversations about them. Okay. All right, now we're on to the sketching part, which is probably the part that some people who voiced that it wasn't their favorite. That it was, yeah. Okay. And that's okay. I chose easy graphs for now. Some of them get a little bit more, but let's just kind of get our feet wet with graphing, and then we'll kind of see. What are some of your strategies that you guys use when you go to graph? And so we are going to sketch the graph and find the given points. I'm going to actually wait to find the given points because I don't want them to throw us off on the way I want you to choose to graph piecewise. But I'm curious, what are some ways some of you guys do it? How do you graph them?
So I like first look at like what it's like less than or greater to or equal to, and then you like go to that point to figure out where you're going to, and then you can start to look at what you're actually going to graph.
Good. So you assess the domain first. Good. So he does the direction I'm hoping that you all can shift to do. Meaning you use this domain right here, you know at x equals 0, it's that graph and down. So it wants from 0 down the first graph. So I'm going to mark that in green. Okay? And the other graph, it wants from 0 up, but it's non-inclusive on this one. So you got to be conscientious of that and just be aware that we don't want that one to be inclusive on this direction when you do graph that one. So I kind of chunk up my domain for which graphs are going to do which. That means they both transition here at 0. That means they both have an endpoint at 0. And that's what Ben was saying, is he finds out where that graph ends and then goes from there. So I call this finding your endpoints first. So how many of you kind of graph the full thing and then erase? Which is okay. I kind of feel like it's more time. I do feel like it takes more time, but it's okay. So there's nothing wrong with it. So if a lot of you guys are like, oh, use your parent function knowledge. You're like, that's a parabola. It's moved down 2. Here's my vertex. Graph the whole thing. Oh, now it's erased from here down. Perfectly fine, but I'm going to teach this way. Finding endpoints and graphing only in the direction just so it avoids erasing. Okay? All right. So let's use this and find our endpoints. So where is this green graph at 0? 0 squared minus 2 puts me down at -2. Is that going to be an inclusive or a non-inclusive?
Inclusive.
It's an inclusive dot.
Yep.
Now, again, you guys realize it's a parabola, but we only want to graph in this direction. So if you know what the graph looks like, you can just draw some of the parent functions and do the mapping that you've done, or you can just plug in on that side. And so that's what I would probably do next. So that's probably what I should have done at the very beginning, was just a t-chart, and realized I wanted to plug in -0 first. Maybe I'll just erase this and just say find endpoints first. That's probably the best way to organize. So maybe I plug in a -1 and see what happens there. -1 squared is 1, right? And then -2, so -3? No, not -3, it's not a negative graph. My brain is not working. -1 squared is 1, -2, so -1. Okay, and you could have also realized this is just the parent function, and on the parent function it goes up 1/1, right? Away. The A, you can't call it slope, but the A, that number is kind of the, you can use it as rise over run for the first point away on all parabolas. And so we can just find a few dots on each graph, and there we go. If you want to go a little further to make it more accurate, you could. So where am I at -2 even, and or so forth. All right, so what is that, -2, 2? So I got pretty close to graphing it, almost correct. All right, let's do the yellow one and do that in the other section of the domain. Find our endpoint. Let's do that. And the endpoint is at,
0.
I have it as 1.
What?
0 what?
It's 1.
It's 1.
Yeah.
So 0 is where it begins, but at 0, 1 is my end point for that portion.
I see.
You see? Okay, good. So 0, 1.
Oh, yeah.
Linear ones are nice. I actually don't even do a t-chart on linears. What should I do from here?
Up 1 over 1.
Up what? Not up 1.
Up 2.
Up 2 over 1. So if you do rise over run, you guys can go up 2 over 1. Right? If you guys look at the slope, are we all aware of that? Because that's the slope.
Yeah.
Yeah.
So from there, I'm able to get my next point. We got it. Easy enough. Now, if they are asking you to find specific points, you can also use those to help with your graph. I just was like pretending those weren't there if I just asked you to graph. How'd that go? Do we all feel okay? There's like a handful who are like, I hate Piecewise. Like, did it go okay for you?
So do I have to do like the point thing you did?
No, you do have to make sure that your graph is not just like a mindless sketch. So as long as you have specific points plotted, that's fine. I don't care about the t-chart stuff if I can see that your graph is accurate. Okay. All right, f of -2. Which function do we plug that one in?
The top one.
Top one. What do we got? We already found it. 2. F of 0. Which function is that one in? Top one.
-2.
Luckily, we already found those on the graph, right? F of 1.
3.
It's on the bottom one. 3.
Yeah.
Okay.
Let's go for it.
Piecewise should be pretty good for most of us. Okay, one more slide. We just got a couple of other things that are going to hopefully challenge you a little bit. So we're not always just going to try to stay super easy and ask you the stuff that you already know. We're going to challenge you a little bit. So sometimes on the piecewise functions, you guys are maybe not used to being asked to find the x and y intercepts. And sometimes they do. So they'll say, graph it, and then find the x and y intercepts. Or they'll just say, what's the x-intercept for this piecewise? And so it kind of throws you off because there's multiple functions you're considering. You don't know where to plug it in. It gets a little confusing when you're plugging stuff into y. Anyway, so we got to kind of see what's going to happen here, okay? All right, so let's go ahead and sketch this, and let's do some extra stuff like domain and range. We didn't ask domain and range on the last slide, right? So let's like challenge ourselves on how you handle domain and range on piecewise functions, okay? So take a moment to sketch it. Let's see if you guys can recognize parent functions, what the graph should look like. Because like, for instance, this first one, when you do the endpoint, don't just do like a straight line, right? Do we know what a cube should look like? Parent functions, okay. So if you guys want to start trying this on your own, I'll kind of quietly work up here as well. And we can see if our graphs come together similarly. Realize that we're non-inclusive at -1 on the first graph.
Yeah.
And that one's going to be in this direction. But we will be inclusive at -1 on the second graph. And then that one will be plotted on that direction. So organize yourself and let's get going. Let's see.
I'll try my best.
So if it just says x-intercept, should we do like x equals or do point?
Intercepts are always written as ordered pairs. That's something you'll notice is always asked of you on our practice quizzes and stuff.
Just on Math Excel.
I know, Math Excel, I do feel bad about that because it does train you a little bit the wrong way. So do get in the habit of intercepts. Try to make that shift mentally, I guess. That's out of my hands on how strict they are about that.
I forgot a comma. That's the whole problem.
What do you know about Math Excel?
Yeah.
Wait.
Bro. What are you doing wrong there, buddy?
It says less than -1.
What are you doing?
You stabbed me. What is that? Get out of here.
That's not cute.
Cause I messed it up, bro. What is a 3?
What is 3? X cubed?
What does it create?
That's
Sorry.
But it's like the squiggly thingy. Almost.
Oh yeah.
Oh yeah, I got it right.
So
Okay, take a moment and have a look. So, did anybody get pretty close to the yellow looking correct, like a cubic? So don't just draw a straight line, we want it to represent the type of function it is. If you want to keep working, you can. So at -1, I found it to be at -1. I knew what a cubic looked like in my mind. I just double checked by plugging in a few points. Went a little further because we could accidentally, if we didn't know that point, we could actually have this draw not correct, right?
Yeah.
So I like to go a little further if I don't really know what the shape is. So make sure it looks like the function they're asking you to, the parent function. That's why we kind of have those parent functions memorized, so that your graph represents the parent function. Notice how we didn't include it on the green, the one down, -1 down, but from -1 up, we did include it on the yellow. A lot of people on negative slopes, because we're so used to going down 2 over 1 when you do a negative slope, a lot of people accidentally go down 1. Did anybody draw it this way first? Because that's super common. Okay? That's okay if you did. So just be cognizant that it's a falling graph. Because that could have been a mistake, but that is a positive graph if you would have accidentally gone that way. So just make sure you guys are being cognizant of the slope. Okay, let's do intercepts. Now, I didn't have to take time to plug anything in because the slope and all that worked itself out. So for the entire function, what are our x-intercepts? Or x-intercepts. Looks like we have one over at -2, 0. And 0, 0. And that's technically our only what intercept? Also our only y. Now let's pretend we didn't sketch it first. I want to go through the process. Actually, let's do domain real quick. What do you guys notice is the domain? Now where can we look for that even without a graph?
The x is greater than or x is less than.
All of that. Whatever that encompasses, that's your domain. So if it happens to cover all rails, you're good to just stay all rails. Now the graph is what you need for the output, right? The y, the range. So what would we say for the range on this one?
-2.
-1 to infinity.
Non-inclusive. Thank you. Who said non-inclusive? Thank you. I'm Lindley. So non-inclusive. Okay. Now pretend. Okay, go ahead.
Sorry, this is kind of random, but it's just like a math Excel question. Like, I just have noticed with the inclusive thing, when it's asking about like increasing and decreasing, it's having us do inclusive. So is that?
It is.
It?
Yeah. I don't
It
know.
is.
It has this music kind of at weird spot.
So at turning points, it shouldn't be.
No, it's not.
It's not.
At ending points,
It
it
is.
might be.
It is.
Okay.
I was so
As a department, we don't agree with it. We personally think that ending points are neither, and we don't know what's happening beyond that.
Yeah.
So on all increasing and decreasing, you should be able to say non-inclusive, and we wouldn't mark you wrong if you did either or, to be honest. Matt, I don't know why Math Excel considers those inclusive, cause I don't think even the college considers them inclusive.
So on their test,
We will be careful that they won't be confusing to you.
sorry, that was random, I just thought of that.
I'm glad. I don't know why in the book that's the discrepancy we run into with that program, not being able to run the exact way we want the college is making us do.
Okay.
So, but I don't know why. But turning points should never ever be inclusive, but ending points sometimes they make it.
So like for the range, if you ever use, if it's like.
Well, range
bottom
is
of
different than intervals of increasing and
Yeah,
decreasing.
but like if it was like the bottom of a parabola, is your range.
That's always inclusive.
That one's
Because there
always
is a
inclusive.
point on that point.
So.
Range and domain are different than
Yeah.
intervals of increasing and decreasing. But range and domain, you have to go actually where it touches, and it doesn't quite touch -2. But on parabolas, that vertex is part of the graph. Yeah, good question. Okay, now algebraically, if we didn't already have the sketch, and I wanted intercepts, what could have I done as far as x-intercepts? Can we have multiple x-intercepts?
Yeah.
Yeah. So we would have taken the time to possibly find out when that first one is equal to 0 and the second one is equal to 0. That would have been the way algebraically we would have found intercepts as far as the x-intercepts go. What's unique about finding the y-intercept? Which graph is 0 only part of?
That one.
0 is only in this one's domain. So as far as y-intercept goes, you need to pay attention to which one's domain it's part of. So you guys would have plugged in a 0 for your x, and you wanted to figure out what your y was when 0 was x. And now we lucked out on this one because our graph included all this, but what if our graph didn't show all those, right? We would have wanted to be able to calculate them. So make sure when you guys are calculating them, for x-intercepts there can be multiple. So I will make sure I find out when y is 0 on all of my equations, right? That's for x-intercepts. On y-intercepts, I can only plug in 0 within whatever one's domain it's part of. Okay? Alright, question.
When for finding the range, if we don't have a graph, is that ever?
You have to have a graph most of the
You
time
have
on
to have a
ranges.
graph.
You'll never be asked really to find range unless there was a graph, or you could graph it. Like you'd have to be capable of graphing something to give us the range. Good question. Okay, let's move on. We're about there. Now I got some uglier ones going on here, and the same type of question, and then I have a word problem. Okay. So this is it copied weird. You know how I take these from PDFs to Excel or PowerPoint. So this bracket did something weird, but the bracket shifted, but that's just pretty much a square root and then the absolute value. Okay. So let's take a moment, and you guys, do you want me to do what I did last time? Try them on your own for a second.
Yeah.
Okay, try them on your own, and then we'll kind of compare.
So you gotta increase the way up.
We just did that.
You're saying
So fast.
consistent.
We just
What the? You don't make sense. She said, like you can speak. That's really rude.
This is kind of fun, man. I enjoy
I just heard that say
it. It's better than geometry.
Ben.
It's okay to enjoy it.
Geometry's the worst.
Ben.
Hey, it's better than trig. You remember trig?
This is so funny. Oh yeah.
Alright, went nice and slow. Is that enough time?
Oh wow.
Okay. Now it's okay if they meet because my domain is still all reals. it's just inclusive on the green, right? So that's okay if they meet. Couple of things. It pays to know the parent function and the shifts. Because by me knowing this is an absolute value, what shift is that?
Left 3.
Left 3. So I knew that if I went left 3, that's my vertex. So I was safe to go up 1 over 1, up 1 over 1. But I also showed what it looks like to plug in and verify. Plug in, verify that it's for sure just going up like that. So it pays to know where your vertex is. Because what if it was a part of a graph and you had to have like this much, right? We can't just assume it was going to be like that, right? You got to know what the parent function and the shift. So it pays to know those transformations and those adjustments.
How do we draw the circle when they touch? Just like
So you don't
try our best to make it.
I probably, where you're not using colors, just fill it in. So like it would be just a filled in, like it's just filled in.
Okay. I just drew an open circle.
So as far as when you evaluate points of those, you would just need to realize it's not inclusive on the yellow one. I wanted this graph to be accurate, and so I didn't want to like be having to go too steep, and so I plugged in something further down. So I intentionally, if you're using mapping, you can realize the parent function moved left 3. So you had a value over 4, 2, and then move that left 3. Or I realized, I want to be able to square root a nice whole number, so I want to be able to square root of 1 and square root of 4. I mean a nice perfect square. Square root of 1 means I'm plugging in a -2, and plugging in a 1 gives me the square root of 4. And so I intentionally picked numbers to plug in that gave me nice things to square root to give me some numbers. So make sure you guys are plugging in some values so your graph looks accurate. Okay, x-intercepts. -3, 0. And is that it?
Yeah.
Now, again, we would have gone through the work if we didn't have a graph to find out what makes this 0 and what makes this other one 0 and solve them both. And we would have just got -3 on both of them, right? And a y-intercept. We didn't calculate that one officially, right? So let's go through the work. Let's go through the work of finding our y-intercept. How do I find my y-intercept? To what? Which one?
The second one.
The only one that it's in its domain, and it's only in the square roots domain, right?
Yes.
So I take it and I'm like, alright, it's only in this one's domain, so it looks like the square root of 3. So we would have been able to say square root 0, square root of 3, or you guys could give us that actual decimal, which is 1 point what? 4 or something, or is it 1.7? So you could have said 1.7 if you wanted to, or you could have said 0, square root 3. Square root 3 is exact. Okay? Domain?
Maybe it's a -2.
Okay, so all reals. And range?
0 with the bracket.
Closed bracket 0 to infinity. You guys are awesome. Okay, I think we're good. I think we were pretty comfortable with Piecewise. I do have this thing. You are going to be asked sometimes real world examples that deal with Piecewise. So this is similar to something kind of on a test that you could see. But you may not even be asked something that's difficult. But at least I want you to be able to be practiced up with it. But it's not difficult. We just have to know how to read stuff, right? So what it's saying is during a particular year, the taxes owed T, that kind of copied weird, but that's a 0.28. Filing separately with an adjusted gross income of X dollars is given by blank. And this is actually real life. In real life, there's different percentages. People in different tax brackets have to pay taxes differently, in different percentages. So they may say, if you make between $0 and $17,900 a year, this is what you have to pay for taxes. If you make between this a year, that's your tax bracket. If you make between this a year, that's your tax bracket. Tax brackets are piecewise functions. You guys ever think of them that way? But it's really not that difficult. What is this technically asking us to do? That's it. It's just asking us to find the tax you'd be paying on a $30,000 income. So which one does $30,000 fall within? The middle one. So we just take the time to do the math, and that is not difficult. We are super capable of this. So as long as you guys have your calculators to help you out, we are good to go, okay? The half of it is just interpretation, and we're interpreting things fine. If you guys do this correctly, I think you would have gotten around $6,073 would have been your tax. So for instance, depending on the way you guys choose to claim, you guys don't have any dependents. I claim 4 children, and so I have 4 kids. Did you know that? Did I not tell you that?
You told us about the
Oh yeah, we still need to do some introductions, but you guys don't know me very well. I don't know some of you very well. So I claim 4 kids. So with 4 kids right now, they don't pull out as much as far as the taxes go. But if I were to claim 0 kids, so it depends on when you want your break. Do I want to have a break on taxes now by claiming my kids? Or do I have a break on my taxes later when I file, and then they realize I have 4 kids and I get a huge return? It's up to you. Do you need to pay less taxes a month and take more home every month? Or do you want a big tax return? And it's all dependent on that. So anyway, needless to say, I would be paying $6,073 if I was making that much money. If I have already paid that much when it was pulled out of my paycheck, and I've already paid $9,000, I get a return because I was only supposed to pay $6,000. Does that make sense how taxes work?
Yes.
Okay. Awesome. And we would do it for $80,000. Which one does $80,000 go in? Awesome. Okay, you guys are good to work unless you want this number really fast. And the time is yours to kind of catch up on what you need. I can start grading exams. I will have them back to you Wednesday for feedback.
Is this one we can retake or what?
Sorry?
I think I'm gonna be leaving for
Wait.
class.
Okay, I'll check the list.
Okay, that's
Well, she have to find a model.